Methanol is readily available worldwide, using a variety of different processes, but can be produced as green methanol, using electrical energy from wind or solar power. It is already used as a marine fuel on a small number of ships, so the technology required for its use in existing marine internal combustion engines is relatively well established and is currently being developed still further. Methanol could also be used to power fuel cells. Since a look at the formula for methanol reveals it is in part a hydrocarbon. It is not carbon-free, but it is often said to be carbon-neutral, because it can be manufactured using captured carbon dioxide or carbon dioxide taken from the air. When manufactured from biomass, the term biomethanol may be used, since the amount of carbon released when burning the fuel is roughly equal to the carbon absorbed by the plant matter during its lifetime. The clean-burning properties of methanol provide a significant reduction in oxides of sulfur and particulate matter emissions, as methanol contains no sulfur and none of the carbon-to-carbon bonds that create particulate matter. The green credentials of methanol depend largely on how it is produced and the emissions from the power generation equipment used to create the energy needed. The source of energy is an important factor impacting the total life cycle, well-to-wake greenhouse gas emissions. For instance, in China, methanol production uses coal, which creates greenhouse gas emissions. Methanol has a lower energy density than conventional fuels and therefore requires more storage space, up to 2.5 times more space than with conventional fuel oils. Methanol is a liquid at room temperature and is claimed to be similar to gas oil in terms of handling and storage, in that it does not require cryogenic or pressurized tanks, although because of its low flash point, the methanol tanks will need to be inerted. Methanol has a higher energy density than ammonia or hydrogen, but less than LNG, and requires approximately 1.6 times the volume of LNG for the same energy output. However, taking into account the lagging needed for LNG, the overall space required for methanol storage is similar. Methanol is corrosive, so special consideration needs to be given to tank coatings and piping materials. Although said to be not toxic to the marine environment, methanol is toxic to humans by inhalation, skin contact, or if swallowed. Methanol vapor is heavier than air and will therefore tend to accumulate at low points. Methanol vapor has a wide flammable range between 6% and 36.5% in air, and burns with flames that are nearly invisible in daylight, so specialized crew training and fire extinguishing practices are needed. Because of its relative maturity as a fuel for marine engines, its availability, and its relatively less complicated storage requirements, methanol has become an increasingly attractive choice as an environmentally friendly marine fuel.